So now let's talk about the divergence test. Divergence test, or as some people call it, the nth term test. What the nth term test basically says, and we have alluded to this earlier, is that if you keep adding a number to itself an infinite number of times, and if that number is anything other than 0, even if it's a very small number such as 1 over 10,000 or 1 over 100,000, eventually you'll be able to cluster enough of them together to produce some number times infinity, which will produce a diverging series. So to ensure that the numbers you're going to be adding to previous to the rest of the series is getting smaller and will potentially produce a converging series. We say that as n goes to infinity of some sequence, it's called the sequence an. As limit goes to infinity of the terms in your sequence, this has to go to 0 for the series to converge. This condition must be met for sequence to converge. However, if this condition is met, it does not mean that the sequence will converge, but this condition has to be met for the sequence to converge. So this is a criterion that a converging series will, but this is not the only criterion that the sequence has to meet. So a converging sequence will have to meet this criterion and some other criterion for it to converge. However, the alternate can be said. So if we know that the limit of n goes to infinity of some sequence an is not equal to 0, then we can say, here I meant to say series. One criterion. One of that must be met. Conversely, what we do know then is that if the limit of the sequence of your numbers don't go to 0, then you're going to be eventually adding some finite number to your sequence. So you're going to be adding some finite number to your series infinitely. And so for that reason, if this condition is met, then we know that the series will diverge. And it's a rather simple test. This is always run regardless, because I look at the series and I think about how the sequence is behaving as n goes to infinity, and I know that if it doesn't go to 0, I don't even need to bother with any of my other tests. This test will tell you immediately whether a sequence or if a sequence diverges. If it fails this, if the limit does go to 0, then we still don't know, right? Because, for example, the sum of 1 over n does not converge, or the sum of 1 over n diverges. But we know that limit as n goes to infinity of 1 over n equals 0. So even if this is equal to 0, then we don't know the behavior of our series. And this was kind of alluded to prior when I added the sum of n over n plus 1. So I know that when n goes to infinity unless equal to 1. And so I'm adding an infinite number of 1s to my series, which means that it will diverge because it's increasing unbounded. And so that is basically the divergence test. Always run this test because it's quick and simple and relatively fast to run.